So we are in the second page of human populations, and just for the sake of planning, I'm only going to do this second page of the populations unit. So I'm going to get into this stuff on the last page in the next video. I just really want to kind of focus on this page by page. So number 8 asks, in what regions of the world is population density the greatest concern? And how is population distribution a food and water security issue? So let's actually take a look at where population density is high, usually in cities. But let's take a look at it like a continent by continent level. What big regions of the world is population set to increase and population set to decrease? From the Gapminder video, that's a throwback, isn't it? With Hans Rosling or whatever his name is. We saw that the two regions of the world that's really growing in population is Africa and parts of Asia, especially China. When we were looking at population growth, we're looking at a couple of African countries in Nigeria, especially South Africa, and then in China, you're definitely looking at India, China, Taiwan. Nonetheless, Indonesia. So here are areas of the world where population is increasing. So how is this a food and water security issue? Well, here you're looking at areas of the world that don't really have many places with a good growing climate and where water security issues are a bit of an issue. I mean, especially if you're looking at sub-Saharan Africa. So vaguely up north here, you're looking at areas where water security is a big issue. And even looking here in the Middle East area, water security is it's actually a big issue. There aren't too many sources of fresh water that are usable, or at least in a sustainable way. So as the population continues to increase and more individuals will require use of these natural resources, you're going to run into water security issues. And there's actually a pretty big conflict that may arise over which regions have rights to different bodies of water, or at least until desalination techniques become feasible and affordable. So that's kind of how population distribution is a food and water security issue. The areas of the world where population is growing the fastest, we tend to see an issue with availability of water and arable land. Explain 2 reasons why a population can grow even if fertility rates decrease. Well, just because birth rates are decreasing doesn't necessarily mean the size of your population is increasing, right? There are 2 big reasons why this may be the case. So one, you're looking at length of life. If the average person grows to be older and older, people are surviving longer, the population is being added to just because kids are still being born. It's not like your fertility rate suddenly disappears. People are just living longer, so the population tends to grow, and you get a lower death rate. That's another reason why population would still grow even though the fertility rate is decreasing. You get a low death rate. Fewer people are dying. So the population seems to just kind of keep growing, even though fertility rates are lower. So now let's look at some math. Perform the following calculation, so all of your work in a logical progression towards the final answer. And here they tell you a city has a population of 50,000 in the year 2012. And the population of the city grows at an annual rate of 2%, so that's your growth rate, 2%. The year in which the population will reach 100,000 is, well, 100,000 to 50,000, that's a doubling, right? The size of your population has doubled. And we actually have a formula for that, right? So doubling time, let's just go with time. Doubling time is equal to 70 divided by r. And this is your rule of 70 that gives you an estimation of how long it will take a population to double. So let's actually go ahead and plug all this math in. Your doubling time, so I'm just going to call that x, is equal to 70. And they gave you the growth rate here is 2%, 70 divided by 2, which means your doubling time is going to be roughly 35 years. So if you started at 2012 and 50,000, and what year will the population reach 100,000? Well, 2012, 35 years later, that's going to be the year 2047. And what year will it reach 200,000? Well, from 100,000 to 200,000 is just another doubling time, and the growth rate hasn't changed, so it will be another 35 years. So 35 years past 2047 is going to be the year 2082. So all we did was look at this doubling time. A country's population was 12 million in 1992, and in 2012 it was 24 million. So here's another doubling time problem, right? We're going from 12 million to 24 million, so that's a doubling of the population. If the population grew at a constant rate, what was the percent growth rate? So now we just need to flip the equation over. We already know the amount of time, right? From 1992 to 2012, this is a 20-year period. So we know it took 20 years for the population to double. So 20 years equals 70 divided by R. Now we just kind of need to rework this math, right? So multiply both sides by R. 20R is equal to 70 divided by 20. Here, R is equal to 3.5%. So this population had a growth rate of 3.5%. And if we want to write an equation for the rule of 70, well, that's doubling time is equal to 70 divided by R, which is the growth rate. Let's actually write that full equation, right? Doubling time is equal to 70 divided by R. Let's keep moving on. Use the axis below to draw and label lines representing the birth rate, death rate, and total population size during the idealized demographic transition of a country. Include written directly into the graph an explanation for each change, blah, 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 blah. So here we have a stage 1 country where you tend to have really high birth rates and really high death rates and generally no population growth. And really the reason for this is you have high infant mortality, right? You don't really have a great medical system. You don't really have a great infrastructure for hygiene and sewage and all that stuff. So stage 1, you have high birth rates, you have high death rates, and you have no population growth. Once you transition to stage 2 and you start becoming a little bit more industrialized, right, your population growth rate starts to increase. The size of your population starts to increase. Your birth rate is still high, but now your death rate is starting to decrease. And your birth rate is high because it's still the cultural norm, right, to have many children. The role of women in society hasn't really changed, but the death rate is going down. So you're getting a huge growth in population. Once you go into stage 3 and you're more or less an industrialized country, right, your birth rates start to go down. Your death rates are almost about the same. I mean, they decrease a little bit more because you have more investment into better healthcare and definitely better food security. But your population still continues to increase, right? And that kind of goes back to the idea we had up front. What are some reasons that a population can grow even if fertility decreases? Well, you have a lower death rate, and the length of time in which people are alive increases. So this is why the population continues to grow in a stage 3 country. Your fertility rates are low, your death rates are low, but people are living longer. So the size of the population tends to continue to increase, but it does begin to level off. Once you get into like a post-industrial society, your population growth rate has stabilized. Your population isn't really increasing anymore. In fact, your population might even be decreasing. And your death rates and birth rates kind of even out. So you're not really having a higher birth rate than a death rate anymore. In fact, you might even have a higher death rate than birth rate because your population growth has sort of stabilized. Here, let's look at age structure diagrams that represent slow growth, rapid growth, and a stable population. So here we have an example of a population diagram that is having kind of, well, I don't want to say a high population growth, right? The population isn't really growing here, but here you have a large birth rate. And then a lot of individuals tend to die off relatively early. So your population isn't really growing. Your population starts to grow once you get into something like this, where people are surviving a little bit longer, and they tend to live it a little bit longer. Sure, you're having fewer kids, but the population is going to grow a little bit. Here you have an age structure for a relatively stable population. The amount of people being born, you're pretty much at replacement level, right? So this is replacement. And remember, your replacement fertility rate is about 2.1%. This is this is the birth rate that's required to kind of replace. That's your fertility rate for replacement level. If you're at about 2.1%, you have a stable population that isn't really increasing. And then here's an example of an age structure diagram for a declining population, right? This population is going to eventually decline because you have fewer births. So fewer people are being born, so you're not going to have as many individuals to replace here, right? This is a high elderly dependency ratio. So this is a high elderly dependency. Here you have a high child dependency. If this population actually has good infrastructure, its population may grow, just because of look at how many people are being born. If this birth rate continues, but the death rate goes down, this population is going to grow relatively quickly. And that's pretty much the end of this video. Next video, we're going to get into the last page, just because there's a really lot to break down when we're talking about the Green Revolution and different policies of these countries that may result in population growth. So that's going to be the next video. Watch out for that.